Okay, we started. Anyhow, hello. I'm here to basically introduce a little bit about what we're doing in the medical devices working group these days, and team members for the regulars who are showing up are Jason, Nicole, Jefro, myself, Milan, Shefali, and Shuah. And you'll probably be hearing from some of them throughout this. I think Milan will take us through a little bit more of the STPA stuff, for instance. And so just wanted to give you the context of us, and input is definitely welcome. So, oops, just go here. So the background, what we've come from is we've been wanting to, look at Linux as a component in a system. And so we started looking at OpenAPS because the sources were available. That was the first part of it. So we had a full system that had some, devices connected to hardware with a person in the loop, and we were able to use that to start to do some analysis. We also found that the community was willing to engage with us and explain when we didn't understand things. And so this is why we started using this application. I think there's some other loop applications that are out there as well. And after we finish this one, we may look at some of the other ones too. But what we wanted to see was Linux is not critical in the sense that it's providing a service underneath. And basically this framework, it's the algorithms and things like that that control the criticality aspect, but we wanted to understand how Linux was participating in this story. So over the last couple of years, we've been doing steady progress on it. And we've sort of got down to level 2, and then we had to go back up to level 1 again, then we had to go back to level 2 as we've been doing the analysis because more factors became visible, which is the whole strength of this type of approach. We're now working towards moving the analysis down to the level 3, what we consider level 3, which is effectively where the Linux kernel is interacting. And that's kind of what we'll be talking about today. The other thing we've done in this group is we've done an investigation on how 62304, which is the standard for medical devices pertain to software of unknown provenance, contrasts to the work that's happening in STPA. And so Jason's been on point with that. So let me sort of move into that. So let me talk about, 62304 is one of the standards that are out there. And we've put out a white paper about the analysis that we've done, looking at what 62304 is calling for, as well as, what is there coming out of the STPA. So Jason, if you're on, if you want to just talk to people a little bit more about that, we can spend a minute or two.
Yeah, that's fine. Hi, everybody. I'm Jason Smith. I work for UL. Safety standards are pretty much my life. So I was happy to get involved with the medical devices group because, there's obviously with medical devices, commonly you're using embedded systems and software. And many of them actually also include third-party software or operating systems like Linux. So I've been helping medical devices group, and specifically also in context of OpenAPS, trying to give guidance on, even though IEC 62304 is intended mainly for certification, those principles can be applied to just about anyone who's interested in making their applications safer, specifically with respect to medical devices. So as one of the activities that we did as far in the medical devices group was to put together a report that kind of summarizes the requirements pertaining to SOUP or software of unknown pedigree or provenance, which Linux would be considered, and how that would pertain or apply to OpenAPS or other applications, medical device applications that are using Linux as an operating system. IEC 62304 is I don't know if I would call it unusual, but many safety standards like the automotive safety standard has more specific or rigorous requirements for operating systems, third-party software, whereas medical devices, basically you can use them, third-party software, things like that, but risks related to it have to be analyzed and addressed. And that's mainly what this paper is addressing, this report is addressing. Trying to see if there's really anything else that I should talk about this. If you're interested in reading more about this paper, please feel free. Obviously, this presentation is going to be shared, and then also the link here. Take a look at it. It's on our GitHub, and you're welcome to review it or request updates or whatnot if you'd like. So I'm happy to answer any questions about it as well. So.
Thank you much. Yeah, anyone, when you review it, if you've got any questions, you've got concern, like, you want to interact, just open an issue, and we're keeping an eye on that. And that's our way for getting further input and refining it. And if there's enough, commentary and discussions, we might have a specific session dedicated to it again in one of the upcoming meetings. Thanks much, Jason. Okay. As part of this, one of the things we're trying to do in the medical devices is, making some of our results visible and available. And as of last week, we just put out a new white paper, best practices for tracing applications running on the Linux kernel. So there we're taking the tooling that's available out in the open source, and we're using it to start to get a handle on tracing workloads through the Linux kernel. And so this methodology has just been published. Shuah and Shefali have done the bulk of the work on this one. And it's already gone through our group's review as well as the TSC review. So it's out there on the processes page. The link is there. And we're, again, looking for input from the community and looking for suggestions on how to improve these things over time. And so, again, open issues if you spot concerns. And Shefali will be talking much more about this tracing methodology tomorrow, and she's got a session on that. So I encourage you to attend that if you're interested in this type of topic. And then the other thing we're working on is we've been collecting a lot of information about the OpenAPS use case and how it works in practice. And we're trying to take our Google Docs and start to move them over to GitHub as well. And so Jefro, who's on this as well, has been helping us to partition and get this structured effectively for communicating this. So hopefully we'll be seeing this emerge in the next session. So what we're doing, like the other you've been hearing earlier today as well, is we are using the system theoretic process analysis approach. And if you're interested in learning more, we certainly will direct you to the handbook. I know we spent a lot of time going through it. What we kind of liked about it was that iterative approach. And we found that in practice. We needed to do the iterations so that we could move it forward. We thought we sort of knew what it was looking like, and then, well, what about this factor? What about that factor? And so the diagrams have evolved and emerged over time, and they form a very good part for doing discussions. So the handbook was able to guide us. We've been iterating and working with some of that community. And the nice thing is we can iterate ourselves lower and lower and eventually take ourselves down to the Linux syscall and interfaces. So, that's kind of where we're heading to right now. Where we are from a project's perspective is we've incorporated some of the feedback from the OpenAPS community so far. We've completed our second level analysis for the unsafe control actions and the loss scenarios. And we're working on clarifying our derived requirements from the analysis we've done. And we want to basically take that back to the OpenAPS community and do a cross-check with them. We've updated the top-level diagrams, which you'll see. And we've been publishing the kernel tracing best practices as a result, which you just saw the reference to. Because what we're going to need to do is get the OpenAPS community to help us get traces of some parts of this system in action, because none of us have exactly the hardware rig available to us, and with the and with the ability to pull in with the information. So we're going to be needing community help to get the level of tracing that we want to do the proper full analysis. But we've got some basic hookups already done and some basic tracing done, and the methodology has been established. So hopefully we'll be able to start moving the analysis in this direction. And then obviously this formal use case document I just referred to. Next quarter, collecting those traces hopefully, and then refining the interactions between our group. And now that we have the information with the Linux syscall information, where it needs to go. And also work with the OpenAPS community on those requirements and see if we can suggest some things to help them. And, setting up the documentation and publishing it out. We're also looking at possibly taking the upstream approach. We've just finished taking upstream the tracing approach that's just been documented and making sure that becomes part of the Linux kernel documentation as well. But these will be things we'll be working on, I think, over the next quarter. With that, I'll turn over to Milan to go into some more deep dive on the OpenAPS diagrams.
Hi everyone, I'm Milan Lakhani. I work for CodeThink and I am a software engineer and experienced in the use of STPA. So after defining the losses and hazards that can happen with OpenAPS, we came up with a control diagram which maps out every component in the system. And you can see every action from each component, which are the downward arrows, and the flow of feedback between the components, which are the upward arrows. This can already be revealing to show the importance of certain actions and feedback, and provides a great backbone for the rest of the analysis. And later on in the process, we've then added these actions to a spreadsheet and looked at how each of these actions can go wrong. So after analyzing the system as a whole, we then looked at what's actually going on inside the OpenAPS system. So breaking down the OpenAPS rig into different components of the application. You can see the different actions there. So we've kind of spent quite a lot of time kind of making sure we've covered everything in the diagrams, and then we've done a level of analysis on each diagram.
Okay, well, thank you, Milan. And if anyone's interested, obviously, please come join us on our calls and as we continue to iterate through and catch up. I guess the next topic we've got is that a level of analysis down towards the kernel. And with that, I'd like to encourage Shuah, if you wouldn't mind, to start talking us through this part.
Thanks, Kate. So what the approach we took here is, you can see we wanted to look at a workload at a higher level, and both static view of the system. First of all, the workload will have dependencies. In our case, OpenAPS runs on Raspberry Pi, and then it has the Raspberry Pi system view. What are the system configurations statically built, supported system calls built, static modules, dynamic modules, and then kernel configuration options. So that is the kind of the static view that maps the OpenAPS. And then we take then comes the dynamic view of the system. What happens when that workload is actually running? Which of the system calls are invoked? And then IACTLs invoked, subsystems in use. And so our goal is to gather large grain and fine grain views. I'll talk about that a little bit next slides. So what we have done to start with is we took OpenAPS and we said, hey, this is a black box. We just want to run that on our system. And then we want to find which systems OpenAPS is using. We used the Linux feature tracing, event tracing, to do that. We enabled event tracing before we start in the start script of the OpenAPS start script, so that it starts before OpenAPS workload starts to use the system. And we gathered traces afterwards. And then we also, to gather the static system view on Raspberry Pi, we used audit system call dump option, where it will dump all of the system calls, supported system calls. As you might know, the supported system calls differ based on the architectures. Not all system calls are supported on all architectures. So we want to get a view of the system calls supported on that particular architecture. In this case, we are looking at Raspberry Pi. And then we used kernel tracing, and then we also looked at which modules, when a OpenAPS workload starts up, which modules are getting kicked off, meaning loaded. LSMod gives us a picture of that. We take a picture of LSMod before starting the OpenAPS workload and after, and while OpenAPS is running, to see how which modules are getting loaded. And then we looked at system calls as well, check system calls script that will tell us the supported status in addition to AUC call dump. This is within the kernel, so it gets updated more frequently, so we trust it more. So we use that as well to get to match up the system calls that are being used or supported and used. Next slide, Kate. So this, I'm going to skip out this slide. We just made the change to the startup script. I already mentioned we had to kick off the tracing. You'll see that change made to the startup scripts here in this diff. Next slide. Okay, so open APS workload characteristics are, it is made up of, it's a collection of Python, JSON code, and several libraries that get loaded in there. And then you can see the tools we used for this activity. strace and TCP dump. These are all the tools we used to gather both higher level and fine grained level workload characteristics. Next slide. So we developed this picture of, we figured out the configurations that are in use, and then the IAC invoked. All of the things we show in yellow here are the ones that we identified through this higher level tracing. Next slide. So this is all documented. We documented these findings in one of the blogs that's published. You can find that blog on our ELISA site. And next slide. So once we had that picture, this work has happened, and then we wanted to go into OpenAPS different commands. Like, for example, what happens when a user goes and says, what's my insulin level, for example. So we started out doing that, but like Kate mentioned, we do not have all the rigs. So we won't be able to use OpenAPS in the way it's supposed to be used without all the hardware and such. So what we chose to do is coming up with a process to analyze any generic workload using tools that are available to us. And then we can take that process and then use that to trace, for example, OpenAPS. We can ask OpenAPS community to follow this process and then trace it for us. And it also becomes a process for anybody that is interested in understanding what their workload is using. So what we used is strace, and then like Kate mentioned, it's already on the GitHub. We published that, and here is a little picture that shows what system calls when we run strace on a date command on any system, the system calls, and what the picture of the system calls it will show. So at this point, we are looking at the very fine grained information. Next slide, Kate. Yes, I think I'm done. So please check out Shefali. Shefali has been helping us, and Milan and Shefali, we have been working together on this. And Shefali has a presentation coming up tomorrow. She'll go into a lot more detail on how to use these individual tools that we have used. Thank you, Kate.
Thank you, Shuah. Thank you, Milan. Okay, so where we are right now, well, what's working? We're making progress. We're still happy with STPA for doing this, for structuring our analysis, because we can sort of approach it from whichever level we want that seems most relevant at the time. and it takes the context into account, which is kind of key. We've been working with the spreadsheets for our analysis, and that's working fine for us in the group, but that's probably where we need to move it to another form for wider dissemination and acceptance. And someone new comes into the group, goes into the spreadsheet, and is sort of lost a little bit, whereas we've been sort of navigating it for quite a while. So building a better on-ramp for people to understand the application and understand the analysis is going to be one of the topics for the workshop in Manchester. And so anyone who's interested in helping us in this direction, please sign up for the workshop. We've got, what else is working is we've got a rather diverse group of participants, and the tracing data is showing us some areas for further investigation, as well as how we can get communities to help us collect the traces. So we're trying to work with the OpenAPS community. That was part of the reason we put this tracing guidance together. As they said, they'd be willing to help us collect the traces, but they needed us to teach them how. So I think that's why we put the priority on this last quarter of getting documentation pulled together for how to do the tracing. So that's kind of what's working. What's kind of what I keep going on is, we want to get more reviews from the OpenAPS community of our analysis. We'd like to get the STPA people reviewing it after we get it transformed into the X format. And obviously we want to get Linux developers to give us feedback as to what we're doing. So the spreadsheet's got to get moved over to Markdown probably. And so that we can, get the wider set of reviewers. And we're sort of looking at starting to do some analysis to compare it to some of the other medical standards that are out there, specifically IEC 6001. Clause 14 has some things that are relevant. So if there are people that are interested in those standards, feel free to join in to the discussions. And with that, I think we're about a few minutes early, but if people have questions or curious about some aspects, the team's here and happy to answer them. And yes, if you go to that site that I just put up there, you'll find out when we have our meetings. Usually our meetings are every week in about a half hour from now. And so we tend to meet about this time every week. And anyone's open to attend if people are interested.
Thank you, Kate.